day of the Leetcode. Okay, so find eventual safe states. Now there is a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by a 0 index 2D integer array graph, okay, where graph I is an integer array of nodes adjacent to node I, meaning that there is an edge from node I to each node in the graph I. So indirectly it is being stated that we have been given the graph, okay, adjacency list, okay, where graph I means that suppose if 0 is being considered, so if uh, at 0 index we have been given this array indicating that 0 is connected to this 1 and 2. So that's what the explanation was. You can see 0 was connected to 1 and 0 was connected to 2, and that's why it was 1 2. Similarly 1 was connected to 2 and 3, that's why it was 2 comma 3 at index 1. Now it should be clear. Now a node is a terminal node if there are no outgoing edges. Terminal node if there are no outgoing edges means its out degree should be 0. Like here 5 is 0 because there is no edge which is away from this node, okay. All the nodes are incoming to this node but there is no outgoing edges. Similarly 6 is also a terminal node. A node is a safe node if every possible path starting from that node leads to a terminal node or another safe node, okay. So now we have been given the definition of a safe node, and what is a safe node is that a node is a safe node if every possible path from that node starting from that node would end up in a terminal node. Like you can see here, the node 2, if I start at node 2, then all the paths emerging from node 2, here it is only one, it will end up at 5, which is a terminal node, so 2 will be a safe node. Similarly 4, you can see all the paths here, it is also only one path, so it would be a terminal node. And the terminal node will be in itself a safe node, because since there is no outgoing path from this node, so I can say that it is also a safe node. Similarly 6 is also a safe node, that's why we have written 2 4 5 6. So yeah, that's all about the problem. If we consider the second example, then we have been given a graph like this. 0 is connected to 1 2 4 3. 0 is connected to 1 2 4 3. 0 is connected to 1 2 4 3. Okay, it is 1, it is 2, it is 3, and it is 4. Okay, so 0 is connected to 2 also, 0 is connected to 3 also, 0 is connected to 4 also. Now talking about 1 is connected to 1 itself, 1 is connected to 1 itself, 1 is connected to 2. Now talking about 3, 2 is connected to 3, and 2 is connected to also connected to 4. Now 4 is connected to itself and also connected to 0. Sorry, I have made a mistake. It was actually 3. It was actually a 4 3. So 3 is connected to 3 is connected to 0 and also connected to 4, and 4 there is no outgoing edge from 4, so I can say 4 is a terminal node and also will be a safe node, okay. And except this, all the nodes will not be a safe node. you can prove that you can see here that from for 0 you can see one of the paths goes to 1 and it will be just looping here and will not go to 4, so that can be a path. For 2 also for 2 it can lead to for 0 the 2 is not a terminal node, okay, or neither a safe node, so it will be a why it is not a safe node, because you can see here 2 to 3 then 3 to 0, it is a path itself, and 0 to 2, so it is also not safe node, so only here the 4 will be a safe node. Now how to think of this solution? If you think carefully, then one thing you should observe, if when will be a node a safe node, when will be a node will be a safe node. Suppose if it's lead to a path, if it lead to a path which is itself in a cycle, I am not drawing the node itself, I am just representing cycle. Suppose it is a cycle, and if it is somehow leading to a path which will result in a cycle, then it will not be a terminal node. It will not be a safe node, because it will just stuck in that loop, and it will not be a it will not end up in a terminal node. Okay, so so I can say that all the paths will not end up to, although some there will be some paths will which can end up to the terminal node, but all the paths through 0 will not end up. Okay, I can prove. Suppose this is the node, it's encountered in the cycle, then it can stop here. Okay, or it can just return to this node again if it is a cycle. That's why it is not a safe node. So I can say all the nodes which are part of a cycle, or the node which led in which any one of the paths outgoing from that node, if it's lead to a cycle, then it will also be not a safe node. Just consider this case, that 0 is not itself in a is a part of any cycle, but one of its path led to a cycle, that's why it is not a safe node. So now only thing remained is to check which nodes are part of the cycle. If either the nodes is a part of the cycle, or if it is leading to a cycle, then it will not be a safe node. So we will just have to check these two conditions. Now let's go to the code. I will first create a visited vector to keep track which node has been visited, because through that only I will be able to say that it is leading to a cycle. Okay, and I will also keep a vector named as cyclic, which will say us either it is a part of a cycle or it is leading to a cycle. Suppose if it is also a part of the cycle, or either it is leading to a cycle, then the corresponding value of the node would be 1 in this cyclic vector. Okay, now we have already been given the graph, so it is not required to, but first of all let's determine what is the number of the nodes. Graph.size. Okay, now I will just run a DFS, bool DFS in d in vector of vector int %g, then vector of int for visited, and then vector of int for cyclic. That's all I did. Now whenever I encounter a node, I will just mark it as visited, and also I am assuming that it is either part of the cycle or it is leading to a cycle. That's why I am visiting it as 1. I am assuming that it is a part of cycle cycle or leading to a path to a cycle. Okay, and I will, if it is not if it is not satisfying this condition, automatically it will be set as 0 at last. That I will explain after I write the code. G of B means I am going to all the neighboring nodes of the current node. If not is equals to visited of, if that is not visited, and if DFS means after calling DFS, if it is a cyclic, if it results in a cycle, then obviously we will return true. Okay, if the DFS of 2 comma z comma visited comma cyclic, then we will return true. One thing you should note here is that if it results in a cycle, let me first complete, then it will be more clear. Okay, if even if it is a if it is leading to a path to a cycle, then also I have to return true. If both the conditions are not satisfied, then only I will reach to this path. If both the conditions not satisfied, then only I can reach to this path. In this part of code. Okay. So if this is so that if it is not satisfying to both the condition, then I have to mark it as 0. Means no, it is I'm not neither a part of a cycle nor leading to a cycle. Okay, and return false means it is not resulting in a cycle. This is indicating. So how can I be so sure that if it is leading to a cycle, uh, if it is not holding both the conditions, then only I will be here. So for proving that, let's consider the graph. It is 0, then 1, then 2, and it is 3, and also 3 here, and 4. Okay, suppose you start as 0. Now you go to 1. Okay, then go to 2. Okay, then mark means marking it as visited, and also assuming that it is either part of a cycle or leading to a path to a cycle. Okay, so okay, now 2 to 0, now it has been marked as visited, so it will return true from here. So if it will return true from here, you can say that you will not reach to this path because your code will return from here only itself. Am I clear? You will return from here only. That's why it will remain marked as cyclic, and also you can see that it is a part of a cycle. All these three nodes are a part of a cycle, so it will remain marked as cyclic. And also now consider this 3 node. Okay, now 3, from 3 to you go to 4, and now when there is no neighboring nodes, no further nodes from 4, you will return, and when you will return, you will mark it as 0. So that's how. Similarly, when you will return to 3, then you will again mark it as 4, mark it as 0, mark it as 0. That's what I was telling, that if it is not a part of a cycle, or if it is even not leading to a cyclic path, then it will automatically get marked as 0 at the end. So I hope that's clear. So let's just call the function for in I equals to 0, I less than n, I plus plus. If not visited, I, then DFS I comma G visited and cyclic. For int I is equals to 0, I less than n, I plus plus, I will push all the whose for I will push all the nodes for whom the cyclic value is 0. If not is equals to cyclic, then answer dot pushback, answer dot pushback I. Sorry, I have not created the vector member answer. At last, I will return answer. So let's see. Sorry, here the name is graph. It is working fine. Let's submit it. So talking about the time and space complexity, I am only running a TFS, so it would take as usual big O of V plus E, where V is the number of vertices and E is the number of edges for running the DFS. And talking about the space complexity, I am storing a graph and also visited and cyclic, so it would also be V plus E. So thank you. That's all about this problem.